In this video, we're going to use the data we collected in our movie survey to implement a machine learning algorithm. And so I've sketched out the outline of the algorithm here. Remember, an algorithm is a step-by-step process for answering a question or solving a problem. So here the problem is that a specific user of this system wants a movie recommendation. And in our example, we're going to let that user be me. I also filled out the survey, so we're going to use my ratings for this algorithm as well as yours. So I'm the specific user that wants a recommendation. Step one was that we had to have ratings submitted by a bunch of different users to be able to base our recommendations on what other people think of the movies as well. Then I'm ready to get my recommendation. And so the third step is to compare my ratings to everyone else's ratings. And the trick here is that the more similar my taste is to yours, the more weight I'm going to give to your opinion. And so to accomplish this step, we're going to compute what are called similarity scores. And I'll go into how that works when we pull up the spreadsheet. After we have the similarity scores, we are going to use those to make predictions for what I might think of every movie that I haven't seen on the list. And then the highest predicted score will be the movie that's recommended for me to watch next. So here are our results from the survey. So I have the people who wanted their names included in alphabetical order, and then the anonymous people second. And I put mine at the top since we're making a recommendation for me. Mine are going to sort of take on a different kind of role than everyone else's ratings. And the next step, remember we already everyone already submitted their ratings, and I'm ready for my recommendation. So our next step is to compute the similarity scores. So I have a space here for our similarity scores. Similarity is, the measure we're going to use is 1 over 1 plus the distance between. And so once we have the distance, we'll have the similarities. The distance measure we're going to use, we're trying to figure out how different are my ratings from your ratings. And so the distance measurement we're going to use is called the Manhattan distance. For example, the distance between me and Amanda on Harry Potter and the Half-Blood Prince is 4. Our ratings differ by 4. But our differences on Pulp Fiction are 0. Our differences on Mad Max Fury Road are 0. Our difference on Skyfall is 3. We're taking the difference between my rating and her rating and then adding up that for every single movie. So this is going to be the sum of the absolute value of the difference between these. So I'm going to take all of Amanda's ratings minus all of my ratings So this will look at each one individually. The difference of 1 for Black Panther, difference of 0 for X-Men First Class, a difference of 1 for the other guys. Absolute value is just saying if I rated it 1 higher or if she rated it 1 higher. It doesn't matter which order we subtract in. We always want the positive version of that. So this is our general idea for this distance measurement. So if we consider all the votes, Amanda is 139 points off from me. If I pull this formula down for the rest of the people, then we see some people are more different on my ratings, some people are closer, but these are the sort of counts of the difference in the votes. The trickiest part here is that these zeros are encoding that we haven't seen or rated the movie. And so we don't want to consider this Independence Day difference a difference of 4 because Amanda hasn't seen it, so we don't actually know how different our opinions are there. So I don't want to count Amanda's zeros. Anything that she counted as a 0, meaning she didn't rate it, I don't want to use it. So I'm going to sum if her ratings are not 0. So I'm going to highlight hers again and say that I don't want them to be 0. That's the only time we're going to include that term. And so if I change the distance there, we start getting closer. So now she's only 80 steps away because we're only counting the movies that she rated. We aren't counting Independence Day anymore. That's no longer a distance of 4. We're still counting Black Panther, X-Men First Class, the other guys, because both of us have seen those movies. The last remaining problem is that we only want to recommend to me a movie I haven't seen yet. So I would want to consider Gravity, where I've given it, I haven't seen Gravity yet. I would want to consider her rating. But I would want to base that rating not on the movies she hasn't seen, but on the movies that both of us have seen. So in order to do that efficiently, I'm going to end up sorting the columns in this spreadsheet according to whether or not I, the user that wants a recommendation, have seen them. So I'm going to use the sort option, and I'm going to actually sort the columns, not the rows. And I'm going to sort on my ratings, which are in row 2. So this will put all of my 5s last, then all of my 4s next to that. Then we get into the movies I rated a 3, then the 2s, then the lone one. I'm sorry, I wasn't a fan of Dunkirk. But closest to the similarity scores, I have all the movies that were on this list that I haven't seen yet. And those are the ones that I don't want to include in my computation. So I really want my computation to start with Dunkirk and go to the right. So right now it's starting at the beginning. I don't want it to start at the beginning, D. I want it to start where my ratings start, which is in A, D. And so now I can see that out of the movies both of us have seen, Amanda's scores differ by a total of 29 points. Heidi's differ by a total of 15 points from me. Josh's differ by a total of 37 points from me. Anonymous user number 8 differs by a lot. But the last anonymous user, only 17. And here we're still computing similarity as 1 over 1 plus the distance for everyone. And what the similarity score can be interpreted as is the percent similar that our movie taste is. So because everyone has, a lot of differences of opinion on movies from me, we're not that similar. 3% similar to Amanda, 5.5% similar to Michael, 6 2/3% similar to anonymous number 4 or number 3. So these are the similarities between our ratings of all of these movies. Now that we have our similarity scores computed, we're able to make predictions for what you guys, your ratings, predict I will think of the movies that I haven't seen yet. And so we're going to have to make space for that in our spreadsheets. I'm actually just going to overwrite these zeros. These zeros aren't important anymore. That just means I haven't seen the movie. So I'm going to highlight all of those. And we're going to replace the zeros with our predicted scores. To get our predicted scores, we're going to have to look at how each of you rated the movie, and then weight that according to how similar you are to me. And to do that, we're going to use a sum product. So I add up your rating times your similarity. So the sum product of D3 to D31, the ratings, times the similarities, C3 to C31. There's 2 tricky parts to this calculation. The first is that it's like calculating a percentage. If you got 3 points out of 4, that's a 75%. You take the number of points, you got 3, and you divide by the total number of points possible, 4. Here we're getting the total number of points, the total rating, but we haven't divided by the total possible, which is the total similarity. So I need to add up, divide by the sum of the similarities. That's tricky part number 1. Tricky part number 2 is that I actually don't want to count the people who haven't seen the movie. So I don't want to count everyone's similarities. I just want to count the people who saw the movie. Here in the sum product, they're actually counted as 0 because you're doing 0 times the similarity. So they are actually not included in the numerator. But I don't want to include them in the denominator. So I need to use that sum if again, where I sum up the similarities, but only if the rating is not 0. So I sum up the similarities as long as the rating isn't 0. And this gets me my predicted score for her based on the ratings of people who saw it. I don't include the people who didn't see it, but I take their ratings and weight them by how similar they are to me. So even though anonymous number 14 loved her, they are only 1.6% similar to me. So they count a lot less than anonymous number 4 who saw the movie and gave it a 2 because they are 4% similar to me, which is still not very similar, but it's a lot more similar than anonymous number 14. So their opinion counted more than anonymous number 14. Well, now I'm ready to do that same prediction for every movie I haven't seen on this list. I need to fix the columns for the similarities because they're always in column C. And once I've fixed that, I will be able to copy and paste for all of the films. Okay, so we have predicted scores for, or predicted ratings for me for every movie based on what you all thought of each of these movies and how similar you are to me. That completes step 4 of our algorithm. We wanted to make the predictions for every movie I haven't seen. That's done. The last step is to recommend the movie with the highest prediction. So we have to find the highest predicted value. I could eyeball it and look at every single rating here, or I can use some more Excel magic. So I want the max predicted rating, which is just the maximum number out of all the yellow cells. So the highest rating is a 4.3398, the highest predicted rating. Okay, we can see where that's coming from because it's right here in front of us, Avengers Infinity War. But if this was a list of, 100 or 1,000 movies and we weren't sure which one it is, we can look for it. I can first try and find out where it is. So I'm looking for the 4.339 in this list of numbers, and I want to know where it appears. It's the 6th number, and if you count over, you'll find that it is the 6th number in this list. And then, instead of having to count ourselves, we can actually look up the movie title. So I'm going to look up in this range. In the first row, I want to find the 6th title. So it tells me that the maximum predicted rating, based on what you all said about each of these movies, is a 4.339 for Avengers Infinity War. There are some other movies it thinks I'll like, some high 3s, maybe some other 4s over here. No, I guess not. But there are other movies that it thinks I'll like a lot, but none of them as much as Avengers Infinity War. And looking at your ratings, most people who rated it a 4 or a 5. And so that's what's bringing up the predicted value, even though you aren't that similar to me, but the ratings are high. So that completes the algorithm. the step-by-step process. First, we had to have everyone rate the movies. That happened as of Friday. Then I'm seeking a recommendation for myself. I had to compute the similarity scores and then use those scores to weight your ratings in order to make predictions for the movies I haven't seen. And once we've done that, we find the highest predicted rating. That's the movie that I'm most likely to enjoy. So in conclusion, algorithms are just step-by-step processes for solving a problem or answering a question. Here we looked at one very specific, more computational algorithm. There was some mathematics involved in measuring distance because there are many ways to measure distance. If we used something other than Manhattan distance, we would have probably gotten other predictions. But similarity is 1 over 1 plus the distance. And once we have the similarity for each user to me, the person seeking recommendations, we can weight the ratings given by each user according to their similarity to me to come up with an overall predicted rating for what I will think of each movie. And this is a good example of how product recommendations work in real internet applications. When you sign on to Netflix or Amazon and they're saying you might like this, they're using a very similar algorithm. They're not putting it in an Excel spreadsheet because they have too much data. They have millions of movies or products and millions of users, so they can't compute it one by one in a spreadsheet. They have some more complicated programming behind it, but the same idea holds. They look at what users are similar to you, what do they also like, and they try to recommend the things that users most similar to you enjoy.